Mhm. Okay. So, guys, hello everyone. Hello to whoever's watching this video. Actually, welcome to Letstute. So, my name is Sanjeev Das, and I'm going to teach you today's topic, today's session. And before starting with anything, let me just say that if you haven't subscribed to our channel, then do subscribe and don't forget to press the bell icon so that you never miss an update from us. Also, we have a lot of courses on science and math on our website. That is www.letstute.com. So do check them out. Okay. So before starting with this, we'll just wait for few people to join this lecture so that we can just quickly cover whatever is going to um, be in this topic. Okay. So hello everyone, whoever's watching this video. Okay, let me just screen share actually. Yeah, so this is our today's topic, what we are supposed to cover: structure of atoms. And in this we are going to cover about electronic configurations and how can you determine what's the valency of an atom. Okay, so these are the two things which we are going to learn today. So be tuned to learn through the whole thing. Actually, in this video, you will also be revising certain things which you have learned in your previous live sessions. So, whatever the concept we have studied in the previous live sessions, we are going to understand it in a systematic way. Okay. So, let me just Yes, I will tell about what is electronic configuration and how can you just draw the electronic configuration based on the atomic number, and how can you find out what's the valency of that particular atom, and how to write electronic configurations. Yes, very good, Vemi Reddy. Okay, so hi Vemi Reddy. Hello, first of all. So let me just say it once more. My name is Sanjeev Das, and I'm going to teach you guys this structure of atoms. And if you haven't subscribed to our channel, do subscribe and don't forget to press the bell icon so that you never miss an update from us. All the live sessions ka update you'll get. And yeah, we have a website actually, that is www.letstute.com. You can just find some amazing videos on math as well as science actually. So you can just find some amazing videos on math as well as science on our website. The links are in the description box. You can just find it in the description box, or in few minutes you'll just find it in the chat box also. So you can just go and check it through the links actually. And it is going to be very helpful for your studies actually. So do check them. Okay. So let's start without wasting any time. So first of all, we are going to study about whatever we have learned in the last few live sessions. So the first thing, whatever we learned was that atoms are neutral. So for a long time, scientists used to believe that atoms are neutral. Okay, so this was the first point. But after that, there was a scientist, J.J. Thomson. He was the first one to discover charge in atom. It was electron, the negative charge. He was the first one to discover it. After that, there was Goldstein, who discovered proton, so the positive charge. So these were the two scientists which actually discovered the charges in atom. So the scientists first used to believe that atom is neutral, and after that they found that atoms have some kind of charges. So there was a need for structure of atom. There was a need to find what is the structure of atom. So because atom was neutral, first they used to believe atom was neutral. It was nothing but it was imagined like a sphere ball, a sphere actually, a metallic sphere. Okay, but after charges were discovered, it was felt that we should know what is the structure of atom, and so discovery, or maybe they started studying about atom. J.J. Thomson was the first one again to give an atomic model of this atom. Okay, so the structure goes like this. First they thought that atoms are neutral. Then it was like charges were discovered. Then there was a need that we should know what is the atomic structure, what is the actual atomic structure. And then there was J.J. Thomson who proposed an atomic structure. He compared the whole atomic structure to a Christmas pudding. Hello Rushikesh, hi. Okay, so what is the meaning of neutral? So when we ready, this is for you. What is the meaning of neutral? Neutral means no charge. Okay, neutral means no charge. There is neither positive charge nor negative charge. Or to be more precise, there must be charges, but they both are cancelling each other. Yeah. So they both are cancelling each other. That means that simply means neutral. It has no charge. Okay, and after that J.J. Thomson was the one who proposed an atomic theory, or an atomic model, sorry, an atomic model. But his atomic model was compared to a Christmas pudding or maybe a watermelon. So the red color edible part, you can consider it as protons, and the seeds actually are like electrons. And the point he proposed was the electrons are actually embedded inside the proton. So he was the one to say that electrons are embedded inside the proton. The whole sphere is made up of proton and electrons are embedded inside it. So J.J. Thomson was successful to prove that atoms are neutral through his atomic model. But there were some scientists who performed some experiments and their results were something different. J.J. Thomson wasn't able to explain, or J.J. Thomson's atomic model wasn't able to explain their results. So Rutherford was the one to perform an experiment, the scattering experiment, the alpha particle scattering experiment. I wanted to ask, why are electrons revolving? No, it's not due to gravity. No, it's not due to gravity, Ravin. No. Good afternoon, everyone. So yeah, we are studying about what is atomic structure. I was on what the Rutherford's atomic model. So he performed an experiment, that is scattering experiment, alpha particle scattering experiment, in which his results were like the alpha particle were bombarded on the gold foil. Most of the alpha particles actually passed straight through the gold foil. And to be more understanding about his experiment, we can take an example. We took an example that a child was blindfolded and he was supposed to throw 10 stones at wall and on fence. So when he threw the stones on the fence, most of the stones passed directly through the fence without coming back, or rebounding back actually. So but when the kid used to throw the stones at the wall, it would rebound back. So you can consider both the situation as the models proposed by the scientists. So the wall can be considered as the atomic model of J.J. Thomson, and the fence can be considered as the atomic model of Rutherford. Okay, it went through it. Now, there were some drawbacks of Rutherford's model also, because he wasn't able to prove that why electrons are actually revolving around the nucleus, or how they are revolving around the nucleus without falling into it. Okay, so the theory was like, if electrons are revolving around the nucleus, they would radiate some kind of energy. Okay, and if they are radiating energy, ultimately they would fall into the center or into the nucleus. But this wasn't happening, because it would make the whole atom very, very unstable. But Niels Bohr was the one to explain this concept very, very properly. He had a model in which he explained about what is discrete orbits. Okay, so he said that electrons are revolving in discrete orbit, and till the time they are revolving in their discrete orbits, they won't radiate energy. So the whole structure was proposed by Bohr. Okay, and of course we know what were the shells actually. It was KLMN, or maybe 1 2 3 4, we can just number it. So now these the placement of all the electrons inside these orbits, or maybe inside these shells, are actually what we are going to study, or in which positions or in which way are these electrons actually placed inside the orbits, or what is the electronic configuration of the atom we are going to study today. But till now in this story we studied about what is electron, how was electron found, and how was proton found. These were the two subatomic particles which were found by the scientists, but still neutron is remaining. Okay, so neutron was found by uh, Chadwick. Okay, James Chadwick, he was the one to find or discover neutrons actually. So in 1932, that is actually after everything being discovered. So this the model proposed by boron and all, after it was everything was done, then discovery of neutron was made. After that, discovery of neutron was made. So Chadwick was the one in 1932. He was the one to discover neutron, which actually had no charge. It had no charge. It was neither positive nor negative. It was actually neutral. And a mass nearly equal to that of proton actually. So it weighed exactly or equal to proton. Eventually it was named as neutron. So what are the certain properties of neutron? Neutrons are present in all the nucleus of all atoms, okay, but except for hydrogen. The pic is not clear. Okay, so who discovered electronic configuration? Okay, so the pic is not clear. How so? Okay, how so? Okay, so let me just say this. So the pic is not clear. I'm so sorry for the pic thing, but I hope you can just read the text over here. Okay, so this was about J. Chadwick, and he said some things that neutron is present in. So this is actually a general knowledge that neutrons are present in all atoms except for hydrogen, and this can come as a MCQ or maybe one-liner thing in your exam. So this is actually a very important thing, that except for hydrogen, all other atoms have neutrons present in their nucleus. Okay, and who discovered electronic configuration? Electronic configuration is just a method to understand how the electrons are actually placed. Okay, what is the placing of these electrons inside the shells? So in general, neutrons are represented as n, as small n. Neutrons are represented as small n, and it's neutral. Okay, mass of the atom is equal to the sum of neutrons and protons. Now what does this mean? We have studied what is atomic mass. Okay, mass of an atom is called as atomic mass, but mass of an atom is actually equal to sum of neutrons and protons. So if we have a atom, it will weigh exactly equal to the sum of neutrons and protons. But a question should come in your mind that we have three subatomic particles in atom. We have electron, we have proton, we have neutron. Then why only we are just adding neutrons and protons to get mass of atom? Why aren't we adding electrons in this? This is a question which you should ask, that why are we adding only neutron and proton to get mass of atom, and not even electron, and not also electron actually? So to answer this question, electrons have actually negligible mass. That simply means they have their masses are actually very less compared to neutron and protons. So they are not considered in mass of atoms. Okay. So this is just a formula which you can remember to find out what is the atomic mass. So the sum of neutrons plus protons is equal to atomic mass of a particular atom, and mass of electrons are actually negligible. So therefore we are not adding electrons in the mass of atom. That's it. Let's quickly jump to our electronic configuration. So this is what we were waiting for. But before starting with this topic, let me just remind you guys, if you haven't subscribed to our channel, then do subscribe, and don't forget to press the bell icon so that you never miss an update from us. Also, we have a lot of courses on science and math on our website, that is www.letstute.com. So do check them. You can just find the link in the description box also. Just check for the links in the description box and do subscribe. Okay, so let's continue with our topic. What is electronic configuration? The placement of all the electrons in proper positions, or in particular shells, is actually known as electronic configuration. And there are certain rules. There are certain rules which we should follow while getting the electronic configuration of a particular atom, because all the atoms follow these particular rules. Okay, so what is the first rule? So it's actually a big rule, so let's read it slowly. Okay, so the maximum number of electrons present in a shell is given by formula n into 2 into n raised to 2. Now what does this mean? Let me just highlight few points. So this particular point which says that this is the formula which we should use to find how many electrons can a particular shell hold. So for example, if I have a first shell, so this is the this is neutron, this is the nucleus actually of atom. This is the first shell, this is the second shell, this is the third shell. Okay, so let's start with the first shell. How many electrons can a particular shell hold? So first shell can hold how many electrons? Second shell can hold how many electrons? Third shell can hold how many electrons? So it is given by a particular formula, and this is the formula: 2 into n raised to 2. That is n square. 2 into n square. And what is this n? N is nothing but the number of orbit which we are looking at. So if we are looking at the first orbit, so we simply replace the n by 1. So if you multiply 2 multiplied by 1 raised to 2, so this is the formula for the first shell. For the second shell, the formula will change. It will be 2 into 2 raised to 2. So 2 ka square is 4, and 4 multiplied by 2 gives you 8. Here the formula for 2 multiplied by 3 square. So 3 square is 9, and 9 multiplied by 2 is 18. For fourth shell, it will be 32. So these are the values which tells us that how many electrons. I hope the slide is clear now, guys. I have just put it on full screen so that you can view it properly. I hope it's clear now, guys. You can just type it in the chat box if it's clear or not. Okay, so it simply gives how many electrons can a particular shell hold. Okay, let's jump on the other point actually. So this says that the maximum number of electrons that an outermost orbit can hold is 8. So this is actually for us. So if you're doing an electronic configuration, so this is the nucleus actually, and if you're trying to do electronic configuration, so the outermost shell, except for the first one, okay, except for the first one, the outermost shells will have 8 electrons. So the first shell will have 2 electrons, only 2 electrons. The second shell will have only 8 electrons, and the third shell can have only 8 electrons to be stable. And after that, it will move to the fourth shell. Okay, so this is the electronic configuration which we are supposed to follow. But of course, I said that our third orbit, or maybe our third shell, can hold 18 electrons. Then why are we just limiting ourselves? Why are we limiting ourselves to only 8 electrons? It has a huge reason actually. It goes to your SPDF blocks, shells, and orbits actually. It's totally a different concept. But to be very clear, or just to keep things simple, just remember the first orbit will have 2 electrons, the second orbit will have 8 electrons, the third orbit will have 8 electrons, and then 2 electrons. Okay, so this is the configuration which we are supposed to follow. So this is actually subjective actually, so this can change according to your atomic number. So but teachers or any other person won't ask you electronic configuration for more than 20 elements actually. Okay, no problem. When we're ready, I'll explain the first rule again. Don't worry about it. Okay. So the first rule actually says that how many electrons, how many number of electrons can a particular shell hold. Okay. This simply says that how many electrons can a particular shell hold, and this is the rule. You should follow this formula. This 2 multiplied by n raised to 2. So look at over. Okay. So n raised to 2. So in place of 2, so in place of n, you can substitute 1, 2, 3, 4, 5, any number actually. So if you want to find out what is the maximum number of electrons which can be present in the first shell, so you'll just substitute 1 in place of this n. So you will get this formula. So 2 multiplied by 1 square, that will give you 2. This simply says that the first orbit can hold only 2 electrons. Then you look at the second orbit. So you get to know, according to the formula, the second orbit can hold only 8 electrons. And then according to the third logic, or according to the formula, the third orbit can hold only 18 electrons. And then the fourth one can hold only 32 electrons, and then so on. I hope you got this point clear when we ready. And others, if you have any doubt, you can just ask it in the chat box. Okay. So let's move to our next note actually. So you should know what is the atomic number for finding the electronic configuration. So this is actually a very important point which is not given in your textbooks, and all this is actually written by me. So to find electronic configuration of any atom, you should know what is the atomic number of that particular atom. Okay. So for example, if we want to find out what is the electronic configuration of helium, if we want to find out what is the electronic configuration of helium, we should know what is the atomic number of helium. So atomic number of helium is 2. So we can draw what is the electronic configuration of helium. So first of all, there should be a small sphere over here. This represents a nucleus. Okay. So this represents nucleus. Then there is first orbit. Okay. We know that first orbit can hold only 2 electrons, and the atomic number of helium is actually 2. So that simply means we can have 2 electrons over here. So first electron and second electron. So these are nothing but electrons. So E minus. And this is also E minus. So electron. Okay. So this is the electronic configuration of helium. The next is about lithium. So lithium has atomic number 3. Okay. So lithium has atomic number 3. Now, if you want to find out what is the electronic configuration of lithium, we can just simply draw it. So this first thing will be your nucleus. This will be your orbit, your shell. You can have 2 electrons in your first orbit. As we know the rules, only 2 electrons are allowed in the first orbit. And then the third electron, the number is 3. So we will have 3 electrons actually. We can have 3 electrons. According to the atomic number, you can decide how many number of electrons you can have. So in this, we can have 3 electrons. So 3 electrons will be placed in this manner. So 2 in the in the first shell, and 1 electron will go in the outer shell or in the second shell. Let's move to the next example. It's about oxygen. We know what is the atomic number of oxygen. The atomic number of oxygen is 8. And according to this number, we can actually find out what is the electronic configuration. So, but before that, let's try to understand, if the atomic number is 8, the number of electrons, there will be 8 electrons. Okay. There will be 8 electrons. So let's quickly draw the structure. So the first thing will be your nucleus. The second will be your first shell. So this is your first shell, and it can hold only 2 electrons. So first electron and second electron. And then comes your next orbit. So it will have how many electrons? 1, 2, 3, 4, 5, and 6. So in total, it's making 8 electrons. I hope you got this thing. So if you want to write what is the electronic configuration, so this drawing thing is not it's diagrammatical representation of electronic configuration. Okay, but if your teacher tells you to write down what is the electronic configuration of oxygen, if she tells you to write down, okay, so you are supposed to write it in this way. So first orbit will have 2 electrons, second orbit will have 6 electrons. So this is the electronic configuration of your oxygen. How to write? Yes. So this is your electronic configuration. Okay. This is the way you're supposed to write your electronic configuration. So 2, 6 is the way you're supposed to write your electronic configuration. Let's look at sodium. So sodium's atomic number is 11, and now from this example we can know that we will have 11 electrons. So let's quickly place them. So the first shell will have only 2 electrons because the limit is only 2. The next shell will have 8 electrons. Now the sum is 10. We have to draw one more electron. So this is the third shell which will have only 1 electron. Okay. So these are the number of electrons in each shell. So first shell has 2 electrons. Second shell has 8 electrons. Third shell has 1 electron. So the electronic configuration which we are going to write is 2, 8, 1. This is the electronic configuration which we are supposed to write. I hope you got this thing. Let me just erase this thing. And okay, so this is the electronic configuration 2, 8, 1. Hello Niju, hello, hi. So but we will write in boxes. You can write it in this way also. You can write it in this way: 2, 8, 1. Just make a square bracket or maybe a circular bracket. You can just make anything. So this is the electronic configuration which you are supposed to draw properly. Now let's look at what are valence electrons. This is actually a very important concept which kids actually don't get. It's actually very simple. So please try to understand this thing properly. But before starting with this topic, let me tell you, if you haven't subscribed to our channel, guys, if you haven't subscribed to our channel, then do subscribe and don't forget to press the bell icon so that you never miss an update from us. Also, we have a lot of courses on science and math on our website. That is www.letstute.com. So do check them. The links are in the description box and also in the comment section. So you can just click on the links and check it. Okay. So let's continue with our valence electrons. So what are valence electrons actually? So the electrons we see on the outermost shell is known as valence electron. So for example, lithium, if we take this example, lithium has atomic number as 3. So the atomic number of lithium is 3. So it will have 3 electrons. But the outermost shell, so this is the outermost shell. This shell has 1 electron. So the valence electron, remember I'm not talking about the valency. I'm talking about the valence electrons. So the number of valence electrons in lithium is 1. Let's take one more example. Let's take example of oxygen. So the electronic configuration of oxygen is 2, 6. 2, 6. Now remember, valency of this particular oxygen is different, but I'm explaining what is valence electrons. So the number of valence electrons are the electrons, the number of electrons in the outermost shell. So number of electrons in the outermost shell of oxygen is 6. So oxygen has 6 valence electrons. Okay, try to understand the concept of valence electrons, then I'll explain you what is valency. Both are different things. Okay, so valence electrons is nothing but number of electrons in the outermost shell. Very good, Vemi, ready. 6. So let's look at this example once again. This is about sodium. So sodium has atomic number as 11. So the electronic configuration of sodium will be 2, comma 8 comma 1. So it will be 2 comma 8 comma 1. Number of electrons in the outermost shell. The number of electrons in the outermost shell of sodium is 1. So the valence electron of sodium is 1. Okay, so this was about what is valence electrons. So if so this is actually a very important thing. So if outermost electron is 8, if the outermost electron if the number of outermost electron is 8, that means they have complete octet. Okay, so for example, neon. So neon has atomic number as 10. So the electronic configuration of neon is 2 comma 8. In the outermost orbit, neon has 8 electrons. Neon has 8 electrons, and the number of and these kind of atoms, and the yeah so the combining capacity, actually what I was explaining this is that it has complete octet. So there are no electrons to be occupied, or it cannot have any more electrons on this orbit. So the combining capacity, or the capacity of it taking any electron or giving any electron, is actually zero, because it has complete octet. And these kind of atoms are called as inert elements. So this atom has actually zero valence electrons. So it has zero valence electrons. Therefore, it is called as inert element. Okay, let's try to understand what is valency. So in this example, in the first example, you can see it's about sodium. It has electronic configuration as this, but in the outermost orbit it has one electron. And the ultimate motto of the electrons of the atoms are actually to give out to be stable, actually to become stable. So they are supposed to become stable. Okay, so they are supposed to become stable. So what do they do? They can either give electrons or they take electrons to become stable. So either they can give electron or they can take electron. So as we know, to become stable we should have complete octet. Okay, and that simply means we should have 8 electrons in the outermost orbit. So in the outermost orbit for this sodium, if we want outermost orbit to be 8, we would have to add 7 electrons. Okay, we will have to add 7 electrons to make the outermost orbit as 8. Or maybe we can just give out one electron, and then the outermost orbit will be this orbit. The second orbit will be the outermost orbit. So there are two possibilities in this condition to understand what is valency. So there are two possibilities to make the outermost shell as a complete octet. So either it can take 7 electrons or it can give one electron. So giving one electron is actually very easy than taking 7 electrons, because the number is actually very small. Okay, so therefore sodium actually gives out one electron to become stable. So the number of electrons which it gives or takes, any atom which gives or takes the number of electrons, that is known as valence electrons, or valency of that particular atom. So valency of sodium is actually 1, because it gives one electron. Okay, in this oxygen thing, the electronic configuration of oxygen is 2 comma 6, and to make the outermost orbit as 8, we can have we can actually add 6 we can actually add 2 electrons. Either we can add 2 electrons, or maybe take out all the 6 electrons, so that the outermost orbit will be 2, and this is actually stable thing actually, because the first orbit can hold two electrons. Okay, so in this thing, giving in this thing, taking electron is much more easy because 2 is actually small. So 2 is smaller than 6. 2 is smaller than 6. uh, Taking electron is much more easy. Therefore, oxygen actually takes two electrons. So it takes one electron and two electron, and now it has 8 electrons in the outermost orbit. So the valency of oxygen is 2. I hope this thing is actually clear to you guys. Okay, so let's try to take one more example about aluminium. Okay, so in this structure we can notice that the outermost shell has one electron, two electron, and three electron. Okay, so the outermost orbit has three electrons. Now to make it complete octet, okay, understand this thing. To make it complete octet, either it can take either it can take 5 electrons. Okay, either it can take 5 electrons or give 3 electrons. Which one is easy? So giving away 3 electrons is much more easy because 3 is less than 5. 3 is less than 5. Therefore giving away electrons is actually very very easy. So outermost shell can have 1, 2, 3, 4, 5, 6, 7, and 8. Let's not write 8 because it's actually stable. If it has 8 electrons in the outermost shell, it's actually stable, so we are not counting 8. Okay, so these 1, 2, 3. If a atom has 1, 2, 3 number of electrons in its outermost shell, then it gives electron. Okay, just understand this thing. If it has 1, 2, 3, it gives electron. If it has 5, 6, 7, then it takes electron to become stable. So it gives electrons to become stable. So if it has 1 electron, 2 electron, or 3 electron in its outermost orbit, it gives electron. And if it has 5, 6, 7 number of valence electrons or valence electrons, which we have studied, then it takes electrons. Okay, so this was all about electronic configuration and valency. But now what about this 4? If it has 4 electrons in its outermost orbit. So carbon is a controversial element actually, controversial atom actually, an element, because it has 4 electrons in its outermost shell. So to make a complete octet, try to understand this thing. To make a complete octet, to make a proper 8, so 4. So either it can take 4 electrons or it can give 4 electrons to become stable. Now in this condition, 4 and 4 both are equal. Try to understand this thing. In this condition, both are equal. Deepak, no need to worry. You can just check out the whole video once again because it's a live session. So you can just you will be able to uh, check out whatever we have completed in the last few minutes. And if you're new to this channel, actually please do subscribe to our channel so that you don't and also press the bell icon so that you never miss an update from us. Please press the bell icon so that you can just go through you can get all the updates from us, so that you will be in proper update, you will be updated actually, so that whenever we are conducting live sessions, you can just see that. So then giving or taking means how can we write electronic configuration? Okay, let me just explain this once again to Vemi Reddy. Then giving or taking means how can we write electronic configuration? Okay, so in this condition, either we can give. Understand this thing. Electronic configuration is completely different, and getting the valency is actually completely different. So writing the valency of this carbon is actually 2 comma 4. You have to write it in the original way itself. So in this also you have to write 2 comma 8 comma 3. Okay, in this condition also you have to write 2 comma 8 comma 3. You don't have to change any electronic configuration. This is about valency, that what is the valency of this particular atom. Okay, so this is actually a controversial state because carbon can either take 4 electrons or either it can give 4 electrons. So carbon is an atom which can either give electrons or take electrons. So it depends according. It totally depends on with which atom it's actually combining. It totally depends on that. So for in this condition, if we take sodium for an example, we have taken this example many times actually, so but let's try to understand this thing. Sodium's electronic configuration is 2, 8 and 1. So it has 2 electrons in the innermost and then 8 and then 1 electron. Okay, and so what is the valency of sodium? It has 1 electron in its outermost shell, so valency of sodium is 1. Okay, then let's look at chlorine. So let's write the electronic configuration of chlorine. So 2 comma 8 comma 7, because there are 7 electrons in the outermost shell. If you want to count it, you can just count the number of electrons actually. So here 1 electron is missing. Okay, so to complete proper octet it will require 1 electron. So the valency of chlorine is 1. It wants 1 electron, okay, and it can give 1 electron. Okay, so this 1 electron actually goes to chlorine, and in this way it can become stable. So this is also stable now, and this chlorine is also stable now. I hope you got this thing. Okay, so let's look at one more thing. Okay, so that's the end of the slide actually. So I hope you have got this thing very properly. I hope the session was actually informative for you guys. I hope you did study how to find out the electronic configuration and how to get what are the valency of the atoms actually. So yeah, so if you have any doubt, please mention it in the chat box, guys. Come on. And for those who haven't subscribed to our channel, guys, do subscribe to our channel so that you will be updated, and do press the bell icon so that you never miss an update from us. Also, we have a lot of courses on science and math on our website. I keep on saying these things, so you can just go through the website and check the amazing courses actually. Okay, so it was a nice session with you guys. Okay, so I think you don't have any doubts, so guys. Okay. Okay, so that's it for this session. Okay, so bye guys, enjoy and do subscribe to us. Okay, bye.